Okay, hello. The quantitative bootcamp, now the last topic under the mass eco. Okay, integration. Okay, and integral calculus, chapter 10 from the prescribed textbook. So remember from the differential calculus we did a while ago, I give you the original equation, but you rather have to derive the first order derivative. So this time for the first part of this chapter, which is indefinite integral, it is the other way around. I rather give you the first order derivative, but you are required to derive the original equation. Okay? And in essence, this is the most important rule. In order to derive the original equation, for all the terms in the first order derivative, you increase the exponent power by 1 n minus 1, and then this term divided by n minus 1. Okay, this is the important rule. Okay, and then there are quite a lot of examples. By the way, you need to add the constant back, but we don't know the constant actually. Okay, so let's look at a few examples. So look at this one. My first order derivative is 9, so my original equation would be 9x because emergent the original equation is 9x, then the first order derivative is indeed 9. But now we have to use the indefinite integral method to derive the original equation, and this is how it looks. Then 9 actually means x to the power of 0, isn't it? Remember, x to the power of 0 gives us 1. 1 times 9 gives us 9. Then the exponent power increases by 1. You see 0 plus 1. Then the term divided by n plus 1, which is 0 plus 1. This is why the original equation is 9x plus c. Let's do maybe one or two more. This one. Let's say the first order derivative is x to the power of 4. So in order to derive the original equation, the exponent value increases by 1. So 4 plus 1, then this term divided by 4 plus 1. This is why it is 1 over 5, and then x to the power of 5. Okay, this is my original equation plus constant. You can differentiate this equation, then you will definitely get x to the power of 4. So you can differentiate your answer to double check that you really get the right answers. Okay, and then maybe one or two more. Let's look at this one. It involves two terms. The first order derivative is a polynomial. Okay, so exponent increases by 1, so 2 plus 1, and then divided by 2 plus 1. So we have 2 here, so 2 third x to the power of 3 here, then 4 x to the power of 6, but the exponent increases by 1, then divided by 6 plus 1, and then minus 4 over 7, x to the power of 7 plus c. Okay, you can also look at this last one on your own. And then we will move on to the economic application. So let's say I give you the first order derivative of total cost, which is marginal cost, and then I give you the total fixed cost. Then you are asked to derive the total cost equation. Okay, and this is how it looks. Okay, so this is my first order derivative of total cost. Okay, I just rename y as I rename x as q now. Okay, and now I apply the rule. The exponent increases by 1. Do you see q to the power of 2 plus 1, and then divided by 2 plus 1 plus 2 q. That actually means q to the power of 1, so 1 plus 1, and then divided by 1 plus 1. Okay, this term actually means 4q to the power of 0. Then the exponent value increases by 1. Then you see the change here. Then this is the answer. But now C would be your total fixed cost 100. Remember, when quantity is 0, total cost would be equal to total fixed cost. This is why C would be 100. So this is my final answer for the total cost. And you can try to differentiate this total cost answer. It would definitely give you the marginal cost, just to double check. Okay. Okay, and then we can also apply the indefinite integral on the revenue question. So total revenue is not given, but I rather give you the first order derivative of total revenue, which is marginal revenue. So now I have to derive total revenue. So this is how it looks. Okay, and then the 10 times, that is q to the power of 0, but the exponent value increases by 1. So you have 0 plus 1, and then divided by 0 plus 1. So you have 10q here. Minus 4 times q to the power of 1 plus 1. Exponent value increases by 1, and then divided by 1 plus 1. Then you have to see. This is your answer. And now the interesting thing is, now for this total revenue, I'm 100% sure that the constant is 0. The reason is when Q is 0, it means 10Q is 0 and minus 2Q squared is 0. When Q is 0, total revenue is definitely 0. This is why the constant must be 0. Okay? And then there are a few more examples, and then you can do it on your own. Okay, so maybe the more complicated type of question would be I will give you marginal revenue and marginal cost, and then I would ask you to apply the indefinite integral method to work backwards to derive total revenue and total cost. Then you would derive the profit equation. Then maybe I will give you a Q value, then you have to work out the profit at that Q value. Okay. So let's see. Okay, the explanation is very clear in the study guide. Okay, again, on the study guide, I focus on the economic applications. So some questions on cost. So I give you the marginal cost, you have to derive the total cost, and the constant is your total fixed cost. And then some questions that I give you marginal revenue, then you have to derive total revenue. And then finally, I give you the marginal product, then you have to derive total product. So all three cases involve the application of indefinite integral. So this is the first part actually of this chapter. Okay? And then the second part, it's called definite integral. You are asked to derive the area under the curve fx between x equals a and x equals b. So you have to derive this area. Okay? And then there are some examples. Okay, let's look at these examples. So this one, I want to derive the area under the horizontal line, actually, y equals 3, between x equals to 2 and x equal to 6. Okay, so again, same old story, exponent increases by 1, something like that. Okay, and after you derive this term 3x, then you substitute, starting with the bigger x value, the upper limit, 6. And then minus 3 times 2, the lower limit. So this is the size, 12. It would be like a shaded rectangle, actually. And let's look at the next one. The area below this line, y equals 8x, from x equals to 2 to x equals to 6. Then again, same old story. Exponent increases by 1, so x to the power of 1 plus 1, which is x squared. Then divided by 1 plus 1, which is 2. So 8 divided by 2, that gives you 4. So you have 4x squared. Then again, the substitution, starting with the upper limit, and then minus, again, substitution, then the lower limit. Then you get the size, 128. And then these two, let me keep quiet for 1 minute and see if you can understand the explanation. Okay. And then the main economic application of definite integral is consumer surplus, actually. So let's look at this. Remember, consumer surplus is equal to the area above the price line and below the demand curve. So if I apply definite integral, first of all, I need to know the lower limit of x, which is q, which is 0. And then this is the upper limit. I have to give you some information, then you will know the upper limit. Then applying the definite integral method, you will derive this whole area from q equals to 0 to q equals to 5, and then the area below this line, okay? But then this area we have to take out this rectangular area. So it will be this whole area minus price times q. We have to exclude this rectangular area. Then the difference would give you consumer surplus, okay? And then let's do a questions here. Okay. So I give you, so the lower limit is 0, the quantity. Then the upper limit, as I said, I must give it to you. It is 9. This is the demand function, okay? So I need to, so again, same old story. Exponent increases by 1, so minus 3q to the power of 2 plus 1 divided by 2 plus 1 plus 355 q to the power of 0 plus 1. Exponent value increases by 1 divided by 0 plus 1. Then you move on to do the substitution, starting with the upper limit, which is 9, and then the lower limit, which is 0. The two constants, they cancel each other's out, so this is that big area. And then minus the rectangular area. Remember, price times quantity. Then this is my consumer surplus size, 1458. I don't think I need the slides anymore, actually. Okay. Let me explain one more. Okay. Consumer surplus, again, the lower limit of Q is 0. The upper limit, as I said, I must give it to you, 6. Okay, this is the equation, demand equation. Again, same old story. Minus 6Q to the power of 2 plus 1 divided by 2 plus 1 plus 265Q to the power of 0 plus 1 divided by 0 plus 1. Then the lower limit, upper limit, then minus the rectangular area, which is price times quantity. Okay. Then for the first part, you have to do some substitution, starting with the upper limit 6, and then the lower limit 0. Again, the two constants cancel each other's out, and then minus the rectangular area, 49 times 6. Then for this question, consumer surplus is 864. Okay, I actually need the slides back. I need to show you the producer surplus story, actually. This is actually the last part of the mass eco. It is here, producer surplus. Okay. Producer surplus is this area above the supply curve and below the price line. In order to calculate the producer surplus area, you first have to calculate this whole rectangular area. Price times quantity, and then minus this area below the supply curve. Then we have to involve the definite integral. Okay, I repeat, price times quantity minus this, I think this is called trapezium area, which involves definite integral. So the difference would give you producer surplus. Now I can really say goodbye to the slides. Okay. Okay, then we will look at two questions. First one, supply equation. Again, I must give you the upper limit of the quantity, Q, which is 5, and price, you can easily work that out with substitution, 155. Producer surplus is the area of the rectangle, price times quantity, and then the trapezium area involves definite integral. So again, same old story, exponent increases by 1 and then divided by, let's say in this case, 2 plus 1, okay? And then after the substitution, starting with the upper limit, Q value, and then minus that other part, substitution, with the lower limit, which must be 0. So let me stop for 1 minute to see if you can understand this. Okay, one more example, then we are done. Okay. Again, producer surplus, I must give you the supply equation. I must give you the upper limit of the quantity. Then substitute into the supply equation, then you will get your price, 135. Then producer surplus, starting off with the rectangular area, price times quantity, 135 times 3, minus that trapezium area that involves definite integral. Again, same old story, exponent increases by 1 and whatever, okay? Then you move on with the substitution, starting with the upper limit Q quantity and then the lower limit Q quantity, 0. Okay, and then I can ask the last type of question, consumer surplus and producer surplus. I just give you demand and supply equation. The only additional question you need to do is just to use simultaneous equations to derive equilibrium price and quantity. And then the rest would be just the same old story. And then you just have to derive total surplus, which is consumer surplus plus producer surplus. So that's it for the Bootcamp Maths Eco session.